I want to take a quick look at some different types of spirals. It turns out that get some pretty simple spirals out of some of our common functions that we're used to from x and y coordinates. So for instance, here's a standard one. Just let r equal theta. Now I'm using a t again here because it's hard to find the theta on the keyboard. So this is just programmed to use a t instead. Here's the graphs kind of get in the way of each other, but this is just r equals t, like we were looking at in one of the other videos. T is along this axis and r is the vertical axis. So this is just like rectangular coordinates here, the red graph. And the bigger, let me zoom out a little bit, I guess here. Let's go to 10. The bigger r gets, sorry, the bigger theta gets, the bigger r gets. That's just the nature of that function. And so as you move around from 0 to 2 pi, right there, you've climbed, r has climbed from 0 out to 2 pi. And I've got this plotted all the way out to 4 pi. So I'm going from 0 to 4 pi. Now, some interesting things happen if you look at the negatives as well. So for instance, if I plot this from negative 2 pi to 4 pi, with these negative r values, let me stop it here when we get one of those negatives. Here we go. Okay, so this is looking in the direction of well, it started off at negative. Started off at negative 2 pi, so it was out here, and so now it's a little further beyond that. So it's looking up into the first quadrant, but r is negative, so it's plotting back here. When it was at negative 2 pi, when it was looking this way along the x-axis, it started plotting back there. And so then it starts coming up and still negative, but now we're looking into the second quadrant, right? At some point over here, we were at negative pi, plotting back behind us. Now we're looking into the third quadrant, but plotting behind us because r is negative. And it comes right down there to the point at 0, and then we start spiraling outward. So it's coming in, and then it's going back out again. Spiral looks a little cleaner if we just take just the positive ones. All right. This is called an arithmetic spiral because each ring is just the same. You add the same amount on each time you go around. So 2 pi gets you here, 2 pi, more gets you up to there. I can change how tight a spiral it is by just putting a multiplier out in front. If I multiply this by 2, this graph goes up twice as fast, the radius gets bigger twice as fast, and so it's a wider spiral. I can make it a tighter spiral by putting a smaller number in there, say 0.5, right? Or make it a little tighter, 0.4, right? You can see as I make that number smaller, the coils get tighter together. You're still going around twice. I'm still plotting from 0 to 4 pi. If you want to see it going around more times, let's go around 3 times, 0 to 6 pi. So that's your arithmetic spiral. It's just straight. Next I want to look at what sometimes they call a logarithmic spiral. And it's interesting because I'm going to use an exponential function to do it. How about just something like, well, let's say 2 raised to the theta power. Now one thing that happens here, I might be better off actually seeing some negatives as well. So I want to plot this from, let's say, negative 6 pi to 6 pi. So I'm going 6 times around total. All right, here's that exponential function. And there's a lot of time that it spends in here where this is negative and you can't even, I'm not negative, this is, r is so small you can't see it. If I were to zoom in on this, so this is where I zoom in, so I'm going to zoom in, zoom in. It's kind of hard to tell as you zoom in that you're actually zooming in at all. Yeah, things look like they're rotating a little bit. But what we're seeing here is the exponential function here never gets down to 0. Right? So this never actually gets right into the origin there. It just gets closer and closer and closer as you're headed through the negative t values there, headed this way. Right? Negative theta values. As theta gets bigger, of course, you spiral out. This is, on any scale, looks the same. The tightness of the spiral is the same. It just keeps spiraling in infinitely many times there as you head in. As theta goes to negative infinity, this just keeps spiraling in closer and closer to 0, never quite getting to 0. Right? I can change how fast or how slowly it does spiral by changing this. So instead of 2, let's say 1.5, right? Or 1.4, or 1. Oops. Or 1.3, or 1.2. That, what just happened? Oh, see, I'm so far in on 1.2 now that I'm seeing the end of my spiral. I'm seeing at the negative pi over 6, the starting point. Right? If I zoom out some, you see it spiraling in more and more there. So let's go out to 1. You've got this spiral going in. Each time you go around, the distance away from the origin gets multiplied by the same amount. Each time you multiply by probably 1.2 to the 2 pi is the number that gets you that much further out. Yeah, so there's a couple different types of spiral. The arithmetic spiral, which is just r equals a linear function, and then this geometric spiral or logarithmic spiral, which is an exponential function. Anyway, spirals.